or a couple of minutes and try to practice using the quadratic formula. You can pause the video and then I'll show the answer key here. So here you can see those values plugged into the quadratic formula. So now you should simplify those three parts separately by typing my calculator, 112 squared minus 4 times negative 16 times 4. I end up getting 12,800. The square root of 12,800 is 113.14. So my answers here would be negative 112 plus or minus 113.14, all divided by negative 32. Remember, when you put this in a calculator, put parentheses around the numerator. So if I take negative 112 plus 113.14, get an answer, divide that by negative 32. One of my solutions is negative 0.04. If I go back and do negative 112 minus 113.14, I get negative 225.14 divided by negative 32. I get my other solution, which is around 7.04. So if you look at that, you can kind of think of the pumpkin launch problem. This problem relates to that. Because if we were to model an equation for the height over time, what we would get is, for part A here, the height is negative 16 t squared plus 112 t plus 4. The 4 is the initial height, the 112 is the initial velocity, and the negative 16 is there from gravity. So if we think of what our solution in the warm-up represents, we do a height-time graph, just a real rough sketch, we're not going to graph it accurately right now. Those two solutions, negative 0.04 seconds, would be just barely to the left of the y-axis, and 7.04 seconds, 0.04 seconds. So the graph would be a parabola that does that. And its y-intercept would be 4. So this unit here would be 4. So if I want to find when it will reach its maximum height, that'll occur right in the middle of these two numbers, because that'll be halfway between. What the shortcut you can do is use this formula. Negative b over 2a gives us the x-coordinate of the vertex, which also gives us the equation of the axis of symmetry. So if I do negative 112 over 2 times a is negative 32. 112 divided by 32 is 3.5. And that is the average of those two x values. So when will it reach its maximum height? At 3.5 seconds. To figure out what its maximum height will be, you then just put that 3.5 in place of the equation for the t's. And you get 200. And that's measured in feet. So basically what we found here is we found the vertex of this parabola. It's the point 3.5, 200. And we found the axis of symmetry, which is that dashed line I drew. And the equation of the axis of symmetry is the equation of a vertical line, which would be x equals 3.5. So that's the type of work you have to do on this worksheet. So to put that together with how we graphed them on Monday, let's go through this example together. So we're going to graph this equation. We're first of all going to determine whether the parabola opens up or down. A is -1, B is 4, C is -1. So because A is less than 0, the parabola opens down. That was the first or second generalized question we did on that worksheet from Monday. So to find the axis of symmetry, I take -4 over 2 times -1, and I get 2. So the equation is x equals 2. I'm going to draw that in as a dashed vertical line. Then I'm going to plot the vertex. The vertex, the x-coordinate of the vertex is 2 from what we just got. And to find the y-coordinate, we substitute 2 in for x into the function. So we're going to get -4 plus 8 minus 1, which is 3. And the vertex then is the point 2, 3. So you'll notice how the vertex is on that dashed line. Then, we can't just draw a parabola downward from there. We have to be more precise. So that's where making the table comes in. So we pick a couple of values for x. And 0 is an easy one to use. So if I put 0 into the equation, I'd get -0 squared plus 4 times 0 minus 1, which is -1. So that's this point, the point 0, -1. Now because I need a point on each side, you could also pick +1. If I put +1 in there, I get -1 plus 4, which is 3, minus 1, which is 2. So the point 1, 2 is another point. Now because of symmetry, what I can do is I can reflect those 2 points across the axis of symmetry. So this point is 1 unit to the left of the axis of symmetry, so the mirror image point is going to be 1 unit to the right. This point here is 2 to the left, so I go 2 to the right, and I get this point. And now I have a nice accurate set of points that I can connect with a parabola. So we draw a parabola through the points. So those are the steps that you should take to graphing those. So take a few minutes and try that for this checkpoint. You can pause the video and then I will show the key. So the axis of symmetry is going to be -8 over 2 times 4, because there's your A, B, and C. Remember the formula for the axis of symmetry is -b over 2a. So we get -8 over 8, which is -1. So the axis of symmetry is the equation x equals -1, which is this vertical line. The vertex is going to have an x-coordinate of -1. And if I plug -1 into the equation, I get 4 plus -8 plus 3, which is -1. So the vertex is the point, -1, -1, which is right there. You'll notice the A is positive, so it's going to open up. So then you should pick a couple other values for x and find the y value. 0 is an easy one because if I put 0 in for x and x, I get 0 plus 0 plus 3, which is 3. So that's this point. And I just noticed my vertex, the scale is wrong, so that should be at -1. And then I'm just going to pick 1 for my other x-coordinate. If I put 1 in there, I get 4 times 1 squared plus 8 times 1 plus 3, which is 15. So that's right there. Plot the 2 points on the other side of the axis of symmetry and connect them. There's your graph. If we talk about domain and range, the domain of this graph is from negative infinity to infinity, and the range goes from negative 1 to infinity. And I should actually use a bracket there because it gets to negative 1. All right, so that's what this slide is kind of explaining, all the relationships there between the maximum and minimum. The vertex is always either the maximum or the minimum. If it opens up, it's a minimum. If it opens down, it's a maximum. So we can use that to solve applied problems, like the suspension bridge. The cables that are highlighted in red are in the shape of a parabola. So if we want to find the height of the cable where the water is at its lowest point, that's another way to say find the minimum, which means you have to find the vertex. So you do negative b over 2a. So in this case, it would be negative 0.37 is b over 2 times 0.000097. So I have 0.37 divided by parentheses 2 times 0.000097. And you end up with x equals 1907.22. So then to find the y value, which is the minimum is the y value of the vertex, I'm just going to plug that in place of both x's. So 0.000097 times 1907.22, the quantity squared, minus 0.37 times 1907.22 plus 549. And the y value ends up being approximately 196.16. So that ends up being, what did it say the units were? The number of feet above the water that this bridge goes. So this problem on the worksheet is actually a repeat of the warm-up. You can skip all of that. And then you have a few other problems where it says find the maximum or minimum. You have to first do this and then take that answer, plug it in for your x's, and you will get the maximum or minimum value. This one is going to be a minimum because the a value is positive, so it's going to open up. Another one where you graph, and another one where you find the maximum or minimum. And then an applied problem, finding the maximum height. So basically find the vertex. Do negative b over 2a, get that answer, plug it into the equation for the x's after you get that, and that'll tell you the minimum or maximum. In this case, since a is negative, it's going to be a maximum, because the parabola will open up. All right, so hopefully you have some time to finish that up in class. If you don't, finish that for Monday. Tuesday, we are going ahead with the test on targets 47 and 48 combined. I am very hopeful I will be back by Monday. So make sure you have the practice test. And I think I have those, so I'll look those over, get those back to you Monday for target 48. And then we'll do a review and practice test for target 47 on Monday also. Have a good weekend, and again, sorry I was absent. Don't worry about that other homework. The homework is just to finish that worksheet.